Okay, good morning. So last time we started talking about primitive functions. I told you that the primitive function is actually the inverse or the reverse process of differentiation, yes? You differentiate, you get a new function, and then you want to find the other way around. So it means that we have to learn how to go back. I give you a function. I ask you, can you tell me what is the function whose derivative is equal to this function? Yes? And actually, we developed some formulas. I don't want to write them down again here. Hopefully you have it in front of you. So that we can use them and find the primitive functions for these functions. So the goal is that. By the way, I told you that there are three ways of asking you to calculate primitive functions with article A or with article the. I haven't talked about the. I will give you an example today. And then I can ask you find all primitive functions. If I ask you find all primitive functions, do you remember we have to put a constant c at the end? So that is a have to if I ask you for finding all primitive functions. But if I ask you find a primitive function, you can choose whatever you like for that constant c, but of course the simplest choice is c equals to 0. Yes? So here, I don't want to be bothered about that constant c over and over again. So I ask you find a primitive function. So in this problem, I always choose c equals to 0. Okay, so I try to make them a little bit harder than usual, but I just want to make sure that you can solve some of them. There are some points in one of them or some of them I will try to teach you those as well. Okay, so for example, I want to find a function whose derivative is equal to this, and this function is a function of x, so it means that when you see a and when you see b, even though they are also letters, but they are not variables for this function. They are just constant numbers written in form of a and b. Yes? So if I want to find a primitive function for this, what should I do? So number one, I have to expand. There is no other way to do it. Because do you remember I told you that even though that's a product of three functions, if I ask you, do you know a primitive function for x? Hopefully you immediately answer x to the 2 divided by 2. And if I ask you, do you know a primitive function for this, you can answer. A primitive function of this, you can immediately answer. But unfortunately, there is no rule that I can find a primitive function for the product of three functions if I know the primitive functions of each one of them individually. So those rules are not in finding primitive functions. So the only way that I can do is just to expand this expression. Okay, so I multiply. And I multiply this inside and then find the answer, multiply this. When I expand that, then I can do the primitive function term by term. So how should I do that? It's very simple, yes? So this is an example that you need to understand how is it going. So x squared plus ax, and then x plus b. And then you multiply it again, so it becomes x to the 3. This multiplied by that becomes bx squared, and then this multiplied by that, ax squared, and then abx. Yes? So that is what I get. Then I can find the primitive function, and usually I told you that if the original function is little f, the standard symbol is to use the same letter, the capital form. So f of x is equal to. And then I told you that even though for the product we don't have any formulas, but for addition we have formulas. We can do them term by term. Yes. So if I ask you what is a primitive function of this, this becomes a fourth x to the power of 4. So which formula I'm using? If c is not equal to -1, do you remember? If I have x to the power of c, the primitive, if this is my f, this is capital F, it becomes 1 over c plus 1 x to the power of c plus 1. Okay, so I'm using that formula. So this becomes that one, but then this is a constant. I told you that because when you see x here, it means that the variable is x, so any other letter, even they are actually constants. So This constant, I don't care about that. I put it here. And I do the same thing for x squared using the same formula. So it becomes 1/3 x to the power of 3. And the same thing happens here. A third x to the power of 3. And then a times b is a constant. So I just write it down. And I use this formula once more for x. This power is 1. So it becomes 1/2 x to the power of 2. And then because they have asked for a primitive function, I don't need to be bothered about that c. I just write it like that. And then let me simplify it. So then it becomes equal to 1/4 x to the 4. I can, if you want to, it is not, of course, mandatory. So here, a/3, b/3, I can write a plus b/3 times x to the power of 3. But this is not mandatory. You can just leave it like that. And then this one, I would prefer to write ab/2 and then x squared. So that is the answer to this problem. Any questions? Yeah, they are easy. Okay, but let me just do them, and then when it comes to the harder ones, I will wait for you to think, so give you time to think a little bit. So here, what should I do? By the way, let me tell you, so if you remember, we did some guesswork to find these simple formulas. Yes, it was easy to guess there, but you see that it was not that easy to guess that function. Yes, if I ask you, can you give me a function whose derivative is equal to this function? It was not easy at all to guess this function. So even though we started with some guessing, of course, after guessing, we proved the formula is correct by differentiating this and showing that this one is equal to that one. But I'm saying that even though we started by guessing, but then we are not, so it means that this is actually not guessing at all. You see, it was not that easy to guess that function whose derivative is equal to this. And if you insist to check your answer, what you're supposed to do, you have to differentiate this function and show that the derivative is equal to that. But I trust my calculations, so let us forego that. Okay, let us start here. Number 2. So what should I do here? What is the first step? What is the first step? Yes?
Expand.
We have to expand. There is no other way here. So I have to multiply these things term by term. So it becomes 1, and then I multiply that. It becomes x minus square root of x. So that is finished. And then I multiply this here, there, and there. Yes? So this becomes square root of x. And then plus x square root of x. But the next one, square root of x times the square root of x, becomes x with a negative sign. Okay, the good point is that most of the terms are cancelled. This one and that one are gone. This one and that one are gone. So what is left is 1 and that one. So this becomes 1 plus x square root of x. And hopefully by the experience you got from the previous session, you know that if I want to solve that, I have to use this formula. So it means that I have to change the exponent form for the square root side. This becomes x times x to the power of 1/2. And then I simplify that, it becomes 1 x to the power of 3/2. So this function is nothing except that function. And finding a primitive function for that is very simple. I have 2 terms. I have to find a primitive function for each one of them. So capital F of x will be, okay, what is a primitive function for 1? Do you remember? If I give you any constant, so first of all, you really don't need to refer to the table. Ask yourself, what is the function? A function whose derivative is 1. A function is enough for us. That is x, yes? But if you want, you can use this. Any constant that I have, its primitive function is cx. That multiplied by x. So a primitive function for 1 is that constant multiplied by x, which of course is x. So this becomes x, and the other one, I have to use the same rule here. Because this rule doesn't work only for the case that c is equal to -1. So what happens here? This becomes plus 1 over 3 over 2 plus 1, and then x to the power of 3 over 2 plus 1. And if I simplify that, this becomes x. This is 5 over 2. 1 over 5 over 2 is 2 over 5. And then this becomes 5 over 2x. Yes? And because I want to find a primitive function, I can stop here. This is completely enough for me, but if you want, you can simplify that. Let me write this with blue. This is not mandatory, but sometimes it is better to learn simplification as well. So I just write this like this, and then I put it back in the form of the square root sign. It becomes x to the power of 5. But x to the power of 5 can be written as x to the power of 2, x to the power of 2 times x. This x squared and this x squared, they can be taken out. So this becomes equal to x plus 2 over 5. 1x comes from here, 1x comes from here. It becomes x squared 2, x squared. But this cannot be pulled out because it doesn't have enough power to go out. So this will remain there. I myself prefer to stop here, but that's completely okay if you stop there. Any questions? Yes? Okay. I want to wait a little bit for you to do this one yourself. And then these ones might be, they are higher level questions, not because they are hard, but you need to think a little bit differently. So I want to wait for you to do this for me, and then we come back together and solve these 3 left problems. Okay. Okay. Might be the time is not enough to finalize it, but at least I hope that you know how to start that, yes? So is there anyone who wants to say how we should start with this? How should I start finding a primitive function for this? What is the first step?
Expanding.
Expanding. And the second step? Assume that you have already expanded this, you get a polynomial in the numerator, but then you have a fraction involved. And I told you that, again, there is no quotient rule for primitive functions. So what should I do here?
You can write the third root of x squared as a factor, and then multiply that as well.
So you mean bring it up?
Yeah.
Okay, that's also working, yes. Yes, that's good. So what we do here, the first step, as you mentioned, I start expanding. So number 3. So here, f of x is equal to, I expand, this becomes x to the 4. I multiply that one is minus 2x squared, and then I will have 1x squared. Then I have minus 2. Then in the denominator, I can write x to the power of 2/3. I can simplify the numerator, so it becomes x to the 4 minus x squared minus 2 divided by x to the power of 2/3. So what Nabila mentioned is correct. So bring this up and then multiply inside. That is also correct. I don't know, but I myself prefer to divide them case by case, but that's exactly equivalent to what you said. So that's up to you which one you choose. So let me follow yours this time. I myself, usually, I don't know for what reason, I don't know, probably I'm used to this way of doing. I divide this by that, I divide this by that, and I divide this by that. Okay, but you told me that you can do something like this. So we can write x to the power of 4 minus x to the power of 2 minus 2, and then I bring it up, so it becomes x to the power of negative 2/3. And then I have to multiply things in, yes? Okay, so let us try to do this in our head. So yes, 4 minus 2/3, because when I multiply this by that, it becomes x to the 4 multiplied by x to the power of minus 2/3. So then I have to write x, and then I add them, yes? It becomes 4 minus 2/3, and then that becomes 10 over 3, yes? Then it becomes x to the power of 10 over 3. So let me skip the detailed calculations, that is easy. Minus x to the power of, the same thing, 2 minus 2/3, it becomes 4/3. And then finally I will have minus 2x to the power of minus 2/3. Yes? So now everything is ready. I can use that formula up there for each one of those terms. So what I write is that capital F of x is equal to x to the power of 10/3. 10/3 is playing the role of that c, so it becomes 1/10/3 plus 1, x to the power of 10/3 plus 1. And I really want you to be able to do it in your head. Of course, it doesn't matter if you write it, but it takes some time. And then it becomes 4/3 plus 1, x to the power of 4/3 plus 1. And finally, I have minus 2, 1/-2/3 plus 1, x to the power of minus 2/3 plus 1. And then let us simplify that. So 10/3 plus 1 is 13/3, but it is 1/13/3, so it becomes 3/13. And then that becomes x to the power of 13/3. And then the same thing here, it becomes 7/3, but it is 1/7/3, so it becomes 3/7, x to the power of 7/3. And then here, it becomes 1/3, 3 goes up, multiplied by that is minus 6, x to the power of 1/3. So that would be your function. And I hope that you agree with me that it was not easy at all to guess that a primitive function for number 3 is this function. Yes? Questions? Okay, but now let us go to a little bit of trigonometry here. Let me write some of the formulas that we need here. So if you go and look at the table that we set up for primitive functions here, I have little f and capital F here. I do not write everything, but let us focus on trigonometry part of that. So the trigonometry part, if you see, we have a formula for sine x. Yes, so that is what you want, a function whose derivative is sine. So if you write cosine, that is not entirely true because the derivative of cosine becomes negative sine. So you have to write this to compensate for that. Yes. And of course, we can do a little bit better. So let me change my color and write this one as well. If I ask you what is sine kx, so that's more or less the same thing. It becomes cosine kx. But if I ask you what is the derivative of that, because of the chain rule, I have to multiply by the derivative of kx, which becomes k. But I do not have k here. So I have to divide by k to get that one. Yes? And if you see, we had this cosine x. I am asking you tell me a function whose derivative is cosine, but that is simple, just sine, because the derivative of sine is cosine. So remember, when you differentiate, you need to be careful about this negative sign. In differentiation, the derivative of sine is positive cosine, the derivative of cosine is negative sine. But in finding a primitive function, that will be the other way around, yes? So a primitive function for sine is not cosine, is negative cosine, and a primitive for cosine is positive sine. You can also write something like that. Cosine kx is 1/k sine kx, yes? The reason is that if you differentiate this, there will be a k coming out because of the chain rule. That k coming out will be cancelling this one, and then I will get that function. But if you see, there is no formula for tangent there. Yes, we didn't have any formula for tangent. So this doesn't mean that you don't know it, but this is not a standard in your book. So this, let me write tangent here. Still, it's a question mark. But what we had is this one. Don't get confused, okay? So if I ask you what is a primitive function for this tangent, you still don't know how to answer that. But if I ask you what is a primitive function for 1 plus 1 over cosine squared, it means that I am asking you, give me a function whose derivative is 1 over cosine squared x. But if you remember, the derivative of tangent is 1 over k, or 1 over cosine squared x. So be careful here. Still, we don't know the question mark here. But if tangent appears on the right column, we know the answer. Yes? So do you remember? Because when we were talking about derivatives, I told you calculate the derivative. Let me just repeat that part. So tangent of x, if I ask you differentiate it, so you have to write it as sine x over cosine x, and then use the quotient rule for derivatives. It becomes the derivative of the numerator, cosine, multiplied by the denominator, which is also cosine, so it becomes cosine squared x, minus the numerator multiplied by the derivative of the denominator. The derivative of the denominator is minus sine times sine is sine squared, and this minus sign becomes positive, yes? And then I have this 1 to power 2. And then this is a famous formula, it becomes 1 over cosine squared x. So you see, when I differentiate tangent, the answer is this. And I told you it's also very good to know that 1 over cosine squared is 1 plus tangent squared. So let me just write this one as well. So you can use this one, or you can use its equivalent form. Okay, so I want you to understand and don't get confused. Here, I have functions whose derivatives are the functions on the left column. But still, there is a question mark here. You will be able to answer it, that is not hard. But at least this was not in the previous lesson. This was in the previous lesson. Tangent appears on the right column. The answer is this one. Yes? Okay, so let us have this. And now go back and try to solve the left problems, yes. So here, then it is easy to calculate, yes? Can you tell me what to do now? So, number 4. I want to find a primitive function for number 4. I have two parts, sine 3x and 1 over cosine squared x. Both of them are in my table, actually. Yes? Sine 3x, I have to use the second row, do you see? Sine kx. So a primitive function for f of x is just simply minus 1 over k, the second row, which is 1 over 3, and then cosine kx. So it becomes cosine 3x. That is the first one, as simple as that. And then I reach to this one here, and that's exactly what I told you. You see, the answer is tangent. So this combination, the answer is simply tangent. So that was actually very simple. That's it. So that is the answer to this problem. But this one is a little bit tricky. I have seen them in the exercises. Remember that if I don't give you this power of 2, it is very simple. If I just ask you what is a primitive function for cosine 5x, you immediately use this formula for k equals to 5. But now remember, and if the power is 2, there is a trick for doing it. And then for higher powers, you have to go to the university to learn how to do that. So probably that would be the final the highest power that you need to know. So for this one, the trick is this. You need to use these formulas. So let me rewrite it for you here. So if I have cosine of 2 theta, the double angle formula, so this becomes, there are 3 formulas for that, yes? 2 of them are important in this context. So one of them is 2 cosine squared theta minus 1. So whatever you have here, you have half of that angle here. Or, you remember we had another formula based on sine. So this is 2 sine squared theta. So these 2 formulas will be helpful if you want to solve the next problem. So how should I do that? Let us concentrate on the first part. I move minus 1 to the other side, it becomes positive 1. So it becomes 1 plus cosine 2 theta is equal to 2 cosine squared theta. And then you divide by 2. So you get cosine squared theta is equal. If I divide this by 2, it becomes 1/2. If I divide this by 2, it becomes 1/2 cosine 2 theta. So this is the way, this is the same formula written in a way that is more suitable for integration. I will use it now. For example, let us just immediately use this formula that is actually the same formula. That is the double angle formula we had before. I have changed the form of that formula into a form which is more suitable for finding primitive functions. Okay? So if I want to solve that problem, I will use this formula and I give the role of 5x to this theta. So what happens? Number 5, f of x is equal to we have cosine squared of 5x. Instead of theta, I put 5x. So it becomes cosine squared of 5x. But this becomes equal to 1/2 plus 1/2 cosine of the double angle. So I have to multiply this by 2. You see theta, 2 theta. Then it becomes 10x. But then it becomes very easy to do that, because if I ask you what is a primitive function of 1/2, yes, it is simply 1/2 times x. And if I ask you, do you know a primitive function for cosine 10x? The answer is this form. Yes? So now I can find a primitive function for this simply. A primitive function for this is 1/2x plus 1/2. A primitive function for cosine 10x is this formula. So k is 10. So it becomes 1/10 sine 10x. So it becomes 1/10 sine 10x. But then what I do, like 1/2 multiplied by 1/10 is 1/20. So it becomes 1/2x plus 1/20 sine 10x. So remember that. If you don't remember this trick, probably that would be hard for you to do. So remember, if you have power of 2 on cosine, the trick is to use this formula. Similarly, if you have a power of 2 for sine, you can use the other formula. So let me write that one here for you as well. So here, I move this one to the left and I move this one to the right. So this going to there, it becomes 2 sine squared theta equals to, I have 1 left here. I move this one to the right, it becomes minus cosine 2 theta. And then I divide by 2. It becomes sine squared theta is 1/2 minus 1/2 cosine 2 theta. Don't get confused, they are very, very similar. So cosine to the power of 2 theta is 1/2 plus 1/2 cosine 2 theta. Sine squared theta is 1/2 minus 1/2 cosine 2 theta. So if you have a power of 2 for cosine or a power of 2 for sine, and you want to find a primitive function, you need to remind yourself of the double angle formulas. These are not in the formula sheet, but I told you that how to derive them if you forget about them, yes? These two are in the formula sheet, so you need to know, you have to look for these 2 formulas so that you can change them and use them here, yes? So this is one of the problems I think in the book that if you don't know this trick, it is not easy to solve. Any questions here? Okay, the last one. Is it? Yes, people can see it. So here, can you tell me what to do with number 6 now? You have everything you need on the board, but I will try to answer that question mark after this problem. So let me bring it a little bit over. Okay, so tell me what to do with number 6. Do you have any idea? So what you need is on the board in this table. So my question is that, can you find a function whose derivative becomes tangent squared x? If I ask you, can you give me a function whose derivative is 1 plus tangent squared of x? Immediately you should be able to answer. If I ask you, give me a function whose derivative is this, you immediately tell me tangent. Yes? But now the point is that I am asking you, can you give me a function whose derivative is just tangent squared without this one? Then how can I answer this? Any ideas? The idea, by the way, is very simple. It's not hard. So the trick is this. I want to somehow use this. The point is that, let me repeat the function here. The function is tangent squared. I need to have a 1 beside it. I do not have it here. So let us add 1 here. But I cannot just simply add 1. I have to do something to compensate for my addition, yes? That is easy. I take it back. Yes? But now let me put them together. It's not necessary, but I'm just trying to make it clear what's happening. So 1 plus tangent squared x, if I ask you, do you know a primitive function for this part? You would say yes, the primitive function for that part is in the table, by the way. It's just simply tangent. And if I ask you, do you know a primitive function for 1? Still you know, that is just x. So this simple trick will solve the problem, yes? So capital F of x is equal to a primitive function for this part is tangent of x. A primitive function for that part is x, and I have a negative sign between. So that is my function. So you see, the algebra was very simple, but if you don't have experience, then it might be hard for you to realize what to do. Now you have enough experience for these problems. Any questions? Okay, let us answer this question mark here. Because I have seen this, I don't remember is it in your book or not, but I have seen it in the Origo book. They have asked to find a primitive function for tangent of x. So it is at the level of your knowledge. So then let me remind you of something. Do you remember, if you go to the table of derivatives, and if I ask you, what was the derivative of ln of absolute value of x, this we did it before this chapter. And the derivative was just simply 1 over x. That was the formula. And then I told you that if instead of x, we have a function of x, call it u, because of the chain rule, this becomes the same formula, 1 over u, but then I have to multiply by an extra u prime. But then I told you that instead of writing 1 over u times u prime, it's better to write u prime over u. So that is a very, very useful combination. So you need to somehow understand, because harder problems sometimes uses this trick. So here, so it means that if I ask you, give me a primitive function for 1 over x, you simply read it from the table and say ln of absolute value of x. But if I have this kind of combination, whose numerator is the derivative of its denominator, that combination should look familiar to your eyes. Whenever you have this combination, you can immediately tell me a primitive function. For example, let us continue this example with number 7 here. Okay, so let me ask you, can you give me a primitive function for this? If you don't remember this trick, it is very hard for you to solve that problem. But then look here, do you agree that this function you see in front of you has the same combination, yes? You have a function in the denominator, the derivative of the denominator appears as the numerator. So you see I have u in the denominator, its derivative in the numerator. So whenever this happens, you need to remind yourself about this trick. So what I ask you to do now, can you tell me what is capital F by understanding this? So what is capital F? Yes?
ln x squared plus 1.
ln of absolute value of x squared plus 1. But in this particular case, I don't really need absolute values because x squared plus 1 is automatically positive. So let me just replace it with brackets. So that is a primitive function. But if you don't know the trick, then that will be a hard problem. But if you know the trick, the problem is very simple. Is that clear? Okay, let me give you another example. So number 8. F of x equals to, so let me write x to the power of 3 plus 3x and then plus 1, x squared plus x. Sorry, plus 1. Yes. For example, we want to do this. Any ideas what to do here? Please start cleaning the board as you think. Any ideas? That is not exactly that combination, do you agree? Because if I ask you what is the derivative of the denominator is 3x squared plus 3. And that is not exactly what is appearing in the numerator. But the difference is just a multiplicative constant, yes? So this, the derivative, what you see here, is 3 times larger than the denominator. So this motivates you to do what? If you want to answer that question. So I would say that f of x is equal to, the denominator is x to the power of 3 plus 3x plus 1. And then I want to have 3x squared plus 3 in the numerator. So let us momentarily write it here. But I cannot just simply change the problem. The problem is x squared plus 1. I have written 3x squared plus 3. To compensate for that, I multiplied by a third. Yes? Why is that? Because 1/3 multiplied by that, it becomes x squared, which is correct. 1/3 multiplied by 3, it's just 1, that's also correct. So I hope that you agree with me. The function in number 8 is exactly equal to this, yes? Is that understandable? Okay, and then if I ask you, if you take this one u in your head, that becomes exactly u prime. And I told you this combination u prime over u should look familiar to your eyes. So u prime over u is exactly that combination. And now I am ready to find a primitive function for f of x. So what is that? It is 1/3 and then it becomes ln of absolute value x to the 3 plus 3x plus 1. Here absolute value is necessary because there is no guarantee that this expression is positive. So then you get this. Yes? And finally number 9 here. That is the question that I asked you. Do you remember that there was a question mark that I didn't answer here? And let me write this one and wait for you. So now f of x is tangent of x. I want you to find a primitive function for this one. This is not in the table that you will get it in the formula sheet, but this is not above your knowledge. So in principle, you should be able to answer a function whose derivative becomes tangent of x. Okay? I will pause the video, wait for you a little bit to see that how it goes. Okay. Do you have the answer? Because the calculations are not heavy. You need to understand the pattern. That's it. If you find the pattern, the answer is just half a line. So what is tangent of x? Yes? So might be, of course, if you don't remember the formulas, that might be a little bit hard for you. So if I want to solve that one, instead of tangent, what can I write? F of x equals to, there is a formula for tangent, and that is sine x cosine x. Do you think that what I have right now is exactly the combination here or not? Because I need something like this combination. If I have something like this, then I know the answer. But do I have that exact combination here? What is the difference with exact that combination? Because if I take this one to be u in my head, I don't know if you remember the formulas in your head or not, because the formulas are not on the board. So if I take u, is this u prime or not? It is minus u prime, yes? Do you agree? Because the derivative of u is not exactly sine, is minus sine. So what I do, I would write it like this. I would write it as minus sine x over cosine x. Do you agree? Because minus sine x is just exactly sine x. So what I have written is completely correct. But now what is the benefit of doing that? Because now if I take this to be u in my head, that is exactly u prime. And u prime over u is exactly the combination I know what to do with. And then there is a negative sign, so it doesn't matter, yes? So the answer is capital F of x is equal to negative sign from here. And then this combination is ln of absolute value of u. So you see that it was not hard and it was exactly at the level of your math knowledge. So even though this is not in the table and in the formula sheet, but you see that if someone asks you what is a primitive function for tangent, you can immediately answer based on the knowledge that you have. Okay, is that clear? So remember this trick sometimes is useful. And then I want to just talk a little bit about the primitive function, give you some examples, and then we are done. Okay. So let me start doing here. So let me write this example here for you. Example. Find the primitive function. Here, this is the first time I am using this article. Find the primitive function capital F of the function f of x equals to e to the power of 5x plus 2 such that, you see, when I use this article there, I cannot stop the problem there. I have to give you extra information, such that, for example, f of 0 is 7. Find the primitive function, which I call it capital F, of this function, but such that f of 0 is 7. So whenever I use the article there, I have to give you extra piece of information, and that extra piece of information is because you need to find the exact value of that integration constant c. That's the whole point of it. So the first thing that you do, you have to find all primitive functions f. So how should I do that? The formula which is useful here, let me write it here. If you refer to the tables that we have, if I have f here, e to the power of cx is 1 over ce to the power of cx. But of course plus a constant. Okay, so I need to use this formula to find all primitive functions for this. So how should I do that? But this is not exactly what you see here, because I have an extra 2, so the trick is to change it into this form. E to the power of 2 multiplied by e to the power of 5x. So this shouldn't bother you, because that's a constant. E to the power 2 is a number. And then if I ask you what are all primitive functions for little f, this is just a constant. And this one, I have this formula, 1 over 5, e to the power of 5x, but plus a constant c. And let me simplify that. So f of x is equal to 1 over 5, and then e to the power of 2 multiplied by that, it becomes e to the power of 5x plus 2 plus c. But the problem is not finished yet, because I have to do something so that that condition is also satisfied. Okay, so this means that if I go and replace 0 for x, the answer is supposed to be 7. So what I do, I put 0 instead of x. F of 0 is equal to 1 over 5 e to the power of 5 times 0 plus 2 plus a constant c. But the problem has already given me f of 0 is 7. So instead of this, I put 7 is equal to 1 over 5. 5 times 0 is just 0, e to the power of 2. So it becomes 1 over 5, e to the power of 2 plus my constant c. And then I am supposed to find c. So I move this to the left. 7 minus 1 over 5 e squared is my c. But the problem is not finished here. Be careful. When you found c, you have to go back and put it here. So the thing that you are supposed to provide as the answer is 1 over 5 e to the power of, let me write capital F. Capital F of x is equal to 1 over 5 e to the power of 5x plus 2. And instead of this c, I put this number. So it becomes minus 1, 5 e to the power of 2 plus 7. So yes? So that is the way that you have to do. So when they ask you about the primitive function, they have to provide you with extra pieces of information. Let me give you another example. Any questions here? So when they say all primitive functions, you have to keep c. If they ask a primitive function, you can choose whatever you like for c. The simplest one is 0. And then if they ask the primitive function, they have to give you extra pieces of information. And then first you find all of them, and then fine-tune c so that it satisfies that or those conditions. And then you have to write it back. Okay, so let me give you another example. The other example, let me tell you this. So let f be a function such that f double prime of x is 6x minus 3. If f prime of 1 is negative 2 and f of 0 is minus 3, determine f. So that's also an example I want you to know. So here it is not the first derivative, it is the second derivative. F double prime is that. So they have given us the second derivative of a function, and they have provided us with 2 extra pieces of information, and we are supposed to find the function f. So what I'm supposed to do, if I ask you how can I find the first derivative is a primitive function for the second derivative, yes? Because you know that if I have a function, I differentiate, so let me put d for differentiation, it takes me to f prime. I differentiate once more, it takes me to f double prime. Yes? If I want to go back from here to here, every time I have to find a primitive function. Yes? So when I want to go back from here to here, so I need to find a primitive function, and when I want to go back from here to here, I again need to find a primitive function. So differentiation and primitive functions are more or less inverses of each other. Yes? So here, if I ask you what is f prime of x, f prime of x is a primitive function for f double prime, yes? So it means that I need to find a primitive function for this. But that is easy, yes? 6x becomes x to the power of 2 divided by 2, so it becomes 3x squared, and then minus 3x. But don't forget to put a constant there. And now, before continue, of course you can continue, but I myself prefer to use this extra piece of information to find c and then continue. Because they are telling us that this should be satisfied. What does it mean? It means that if I go to the first derivative, replace x with 1, the answer is supposed to be minus 2. So what happens? F prime of 1 is negative 2. So this means that if I go here and replace x with 1, the answer is supposed to be minus 2. And then you see that I immediately find c. Okay, that is a coincidence. This 3 and 3 are cancelled, so c becomes exactly minus 2. And when c is minus 2, I put it back here. I found my first derivative. So therefore, my first derivative is equal to 3x squared minus 3x and then minus 2. And then I do this process once more. I want to go to f. I have f prime, so I have to do primitive function process, yes? So f of x is a primitive function for f prime. A primitive function for this is x to the power of 3 divided by 3, and those 3's will be cancelled. It is just simply that. And a primitive function for x is x squared over 2, so it becomes minus 3 over 2x squared. And then this becomes minus 2x, but be careful. You have a constant again. Because I have already used letter C here, let me choose the name, for example, to D. Okay, so d I used here, so let me write it as, I don't know, alpha or whatever, a constant. Yes? But then I have this extra piece of information now. So it means that if you go to your function, replace x with 0, the answer is supposed to be minus 3. So f of the 0 is minus 3. So this means that if I replace x with 0, the answer is supposed to be minus 3. But here everything is cancelled. I find alpha to be minus 3. So the answer that you have to provide is this function replacing, substituting minus 3 for alpha. So this becomes f of x is equal to the x to the 3 minus 3 over 2x squared minus 2x plus, minus 3. Any questions? So then I would say that everything for primitive functions is finalized, and then we continue with really integrals after the Christmas break. Any questions? Okay, thank you.